In this video, we are going to look specifically at what the rules for exponents are and what some of the power rules for exponents are, and then we're going to do some examples so you can see how simplifying of these ideas works. So first things first, these are all the rules that we have, and so you can see how they're broken down. So you have the product rule, so that's broken down into same bases with different powers, means you add them. Okay, so here what we have is that you are going to add the powers. For the quotient rule, what you're going to do is we are going to subtract. Specifically, we are going to subtract top minus the bottom. Okay, so here we're going to do top number minus the bottom number. For your power rule, this is where we multiply the powers. When we do raising product to a power, essentially what that means is that we have to take whatever the power is on the outside and apply it to all pieces on the inside. Once we apply it, we then follow the different rules that we have. Raising a quotient to a power is the same thing. A quotient is your fraction, so you would apply your power to both the numerator and denominator. And then a negative essentially means that you are going to flip the reciprocal to make it power. Okay? So what we're doing here for your negatives is we do what's called flip it and then change the sign to positive. Okay, and so as you can see here, if I have just a single term to a negative power, it becomes 1 over that term. Notice the power is positive. If I have a quotient here where top and bottom both have negatives, notice they both flip, so the B goes to the top, A goes to the bottom, so that their powers are positive. Now, the biggest thing that you always want to remember is that you cannot leave a negative power. So no matter what you're doing or how you're simplifying, if you end up with a negative power, you must go that one extra step and apply the negative power rule to it. Okay. So here I'm going to show you examples using actual examples of these different rules. So first, if we look at the product rule, for example, let's say that I had x to the 5th, and I'm going to multiply that by x to the 12th. Well, the rule says we add, so this is going to be x to the 5 plus 12, which equals x to the 17. Okay, so you add the powers, you keep the base the same. Now for your quotient, it's going to be the same thing. And so let's say, for example, that I had x to the 6th over x squared. So in this case, we would subtract, so we would keep the base, and then this would be the top number minus the bottom number, which is going to be x to the 4th power. Okay, so again, we subtract top minus bottom. The power rule would say what happens if I had x to the 5th and then I'm taking it to the 3rd. Okay, so in this case, we would multiply. We keep the base, and then this would be 5 times 3, which is going to give you x to the 15. Raising a product to a power is simply going to mean that, let's say I had 4 to x to the 7th, and then I'm going to take this up to the 3rd. So what happens is I have to apply, or take this 3 and apply it onto the 4 and apply it onto the x to the 7th. And so here this would end up being 4 to the 3rd, and then this would be x to the 7 times 3. You actually want to So for this one here, 4 to the third, you want to do the math. So 4 to the third is going to give you 64. So this would be 64 and then x to the 21st. Okay. So when you're working these out, anywhere that you can do the math, you need to make sure that you do follow through and do the math to its completion. Now, if I want to raise a quotient to a power, let's say I had 5x to the 4th over 3y squared, and I'm going to take this whole thing and raise it to the third power. Well, just like before, your power has to be applied to every piece in your equation. So we're going to take this 3 and it's going to be applied onto the 5, it's going to be applied onto the x to the 4th, it's going to be applied onto the 3, and it's going to be applied onto the y squared. So we're going to apply it to all pieces. So here this is going to end up being 5 to the third, x to the 4 times 3, and then on the bottom you're going to have 3 to the third times y to the 2 times 3. So just like before, you always need to make sure you do the math. So 5 to the third is going to be 125, and then I'm going to have x to the 12th. And then on the bottom I have 3 to the third, which is going to be 27, and that's going to be y to the 6th. Now the last thing you want to look at is, does 125 over 27 reduce? Okay, and so you can reduce that as far as you can. Otherwise, there's nothing else to do because our variables are different. Now the very last one is your negative power. So for example, let's say I had x to the negative 5th. So we're going to use the flip it idea. So we're going to flip the reciprocal, which makes it 1 over x to the 5th. And now in this case there would be nothing else to do. My sign has changed to positive, and so I'm good to go. Alright, so let's put this into action. And what happens is you're given problems where you are asked to simplify completely, and in doing so you have to recognize the different rules that you have in play. So if we look at these two here, the first thing that we have, or the first rule that we are going to work with, is we have to multiply the coefficients we then have to add the powers and see where we stand. Okay, so here what we're going to do is we're going to multiply our coefficients. So this is going to give me 5 times my negative 7. I then have m squared times m to the 4th, and I have n to the negative 3 times n. Okay. So now that I've put them all together, I'm going to go ahead and multiply. 5 times negative 7 is going to give you a negative 35. This is going to be m to the 2 plus 4 and n to the negative 3 plus 1. So if we reduce that, we get negative 35, m to the 6th, n to the negative 2. Now here I have a negative power, and so I have to fix the negative in order to finish. And so fixing my negative power essentially says that I have to flip it. Okay, so here what's going to happen is that this term right here has to come down, and it's going to move to the denominator. So with that, this means that we're going to end up with negative 35 m to the 6th, and the whole thing is over n squared. Since my power is now positive and there is nothing else that can reduce or cancel, that's how I know that I've completed my problem. Alright, let's look at another one here. So again, just like before, the first thing I have to do is identify the rule I'm using. And in this case, if you look at this sign right here, this tells us that we have the quotient rule. So the quotient rule that I'm dealing with says that I have to divide the coefficients. I then have to subtract the powers and see where I end up after that. Okay? So first things first, I'm going to kind of separate everything out. So here I've got 56 over 8. I have x to the 8th over x to the negative 2. And then I have y to the negative 4 over y to the 5th. Now I separated them all out because you want to look at these as kind of individual problems. So first I have to look at 56 over 8. So I want to actually divide that down, and 56 over 8 becomes a 7. I then have x, and this is going to end up being 8 minus a negative 2. My last one is going to be y, and I have negative 4 minus 5. So here I need to simplify down. So I have 7, and this is going to be x. Negative and negative is positive, so this becomes x to the 10th, and this is y to the negative 9. Now just like before, I now have to fix the negative power. And so what that means is this y to the negative 9 is going to be the one that now is going to move to the denominator. So here I'm going to be left with 7x to the 10th in the numerator and y to the 9th in the denominator. Alright, let's go ahead and make things a little bit more complicated, and all it means is that we're going to have a few extra steps. So in this case, we have to treat this problem kind of like we do an onion. So we're going to work from the inside out. So the first thing you're going to do is we are going to simplify inside the parentheses. Okay? So if we look inside the parentheses, it means we're going to ignore this negative 3. Looking inside the parentheses, what you'll see is that we have the quotient rule. So just like before, this rule says that we have to divide the coefficients, and then we have to subtract the powers. So with that, I'm going to look just inside the parentheses, and I'm going to kind of break them out. So I have 125 over 25. I have a to the 4th over a to the negative 7. I have b to the negative 5 over b to the 12. And I have c over c to the negative 2. So just like the other one, I'm going to look at each of these as individuals. So 5 over 25, or sorry, 125 over 25 is going to become a 5. And then this is going to be a to the 4 minus a negative 7. you're going to have b to the negative 5 minus 12, and c to the 1 minus a negative 2. So now that we've applied the rule, we just simply have to simplify. So this is 5. I have a to the 11th. I have b to the negative 17. And I have c to the 3rd. Now, the thing that I have to remember about this is that this was still inside my parenthesis with negative 3 power. So once you reduce the inside as much as you can, so notice we took this from a quotient down to just a single term, we now have to work with the outer power. And so here what we need to do is we have to distribute the outside power to all inside terms or powers. So what that means is that this negative 3 here has to be applied to the 5, to the a to the 11th, to b to the 17, and to c to the 3rd. Okay? So the distributing idea is very similar to the distributing idea we use when multiplying, in that it gets applied to each and every term. So here, this is going to end up being 5 to the negative 3rd, and then we're going to have a to the 11 times negative 3, b to the negative 17 times negative 3, c to the 3 times negative 3. So here 5 to the negative 3 still holds true, so 5 to the negative 3. Then my a is going to become negative 33. This is going to be b to the 51 and c to the negative 9. The last thing we have to do is we have to fix the negative powers. Remember, that means we are going to flip it, and then we're going to change the sign to positive. So here this means that we're going to look at c to the negative 9, which is going to shift down. We're going to have a to the negative 3rd, or 33 is going to shift down, and we have 5 to the negative 3 is going to shift down, and all of these are moving to the denominator. So with that, what happens is the only one left in the numerator is b to the 51. So b to the 51 is on top. We then have 5 to the 3rd on the bottom, a to the 33, and c to the 9th. The last thing that we have to do is, for my a, we need to do the math. So that makes our overall result b to the 51 over 125, a to the 33, c to the 9. Okay. So in a nutshell, that is what you would need to know in order to play around with the rules of exponents and the power rules to exponents. So if you have any questions with these examples, please let me know. Otherwise, I hope you enjoyed, and I'll see you next time.